Combining like terms. That just means that if you have a single number by itself, whether positive or negative, you're going to be able to put it together. The word combining means that you'd be adding it. So you're taking one part, combining it with another. Um, like terms would also mean that any number that's in front of a letter, which would be a coefficient in front of a variable, that would represent multiplication. So like 7x would be 7 times a number we don't know. That could be combined, whether positive or negative, with another coefficient and variable of the same letter. So 7x and negative 2x could be put together. So what I'm going to do is go through a couple problems of very simple combining like terms and then have that go into multi-step equations, which is basically just doing some combining like terms before you solve a two-step. So combining like terms, everything that we've been going over in algebra so far, you can see that the math is not difficult. The thing that's the most difficult is maintaining some sort of structure, a system that goes with all of this math and learning the grammar that goes with it. So whenever we're talking about combining like terms, you're going to circle the number and whatever matches it in its sign. So you can see that it was a negative 6k, and the operation can also represent what kind of number it is. So that's a positive 7k. Since we know that we're combining all these like terms, everything will be addition. So you have a negative 6 plus 7, and you can put the k's there. We know that we're putting those together because it's both a number followed by the letter k. Any variation of that, like negative 6k squared plus 7k, those are not like terms because of the 6k squared. In your calculator, the part that you'd be looking at mainly is right here. If you have negative 6k's and then you add 7k's to it, you're going to end up with a positive 1k. Proper format is whenever there's a 1 in front of a variable, you can it's already assumed that if you only write the variable, for example, k, that there's an invisible 1 right next to it. There's nothing wrong with writing 1k, but you can also write just k. Either of these answers are okay. Combining like terms. So what we're going to do is, all right, so I see 12 has R after it. Now I'm going to look at the next part. All right, so does 8 have an R? No. Does 12 have an R? No. But I do see two things that don't have R, so that means I can circle the number and its sign. And I know that I'm going to be combining these things, so I'm going to have negative 8 plus negative 12. And when we put 8 negatives and 12 negatives together, we end up getting 20 negatives. So one part of this is rewriting the problem with stuff that wasn't used. After I use it, I'm going to mark it out. That way I can see what I have left over. 12R. So all I'm going to do is write 12R. It was at the front. I'm going to keep it at the front. I'm going to write the answer that I got, negative 20, right next to it. There we go. Combined like terms. Basically what you're doing is you're narrowing down the stuff that can be combined. You're combining it and you're making it look like it's less. You're organizing stuff before you start solving anything. Oh, wow. Okay. So I can see that there's an N all by itself. There's no number in front of it, but we also established that whenever we see a variable by itself, that the coefficient or the number in front of the letter is going to be a 1, because there is one N sitting there, no denying it. There is a 10, but it doesn't have an N after it. All right, so that means we can't put it with this N, and we can't put it with this 9N. There's a 3, and it doesn't have an N after it. All right, so we have two things that we can combine here. Circling that, there is no sign in front of it. That means it's positive. So we know we're going to be combining. We're going to do a 1N. And we're going to circle the number and its sign, and we're adding a 9n. So we have a positive 1n and a positive 9n that we are combining. And if you want to put positive and positive, that's cool too. So 1 plus, if you have an n and then you add 9 more n's to it, you end up having 10 n's. 10n. Okay. I use these two things up. See ya. Now the only two things left are a negative 10 and a negative 3. I know I'm going to be combining these two things, so negative 10 plus negative 3. 10 negatives plus 3 more negatives gives you 13 negatives. And look, there's our answer, 10n minus 13. If you want to rewrite that to where it looks a little more close together, that's cool too. 10n minus 13. Just combining the stuff that can go together. Okay, so you can see here there are two things, and it looks like it's just a simple problem. All right, so you have negative 4x's and you're taking 10x's away. We know that we are combining the like terms. It's a number followed by the same exact letter, x. There's not an exponent. It's not a negative exponent, anything like that. So we're going to circle the number with its sign. Number with its sign. So we're going to add a negative 4x and a negative 10x. If you had negative 4x's and then you added 10 more negative x's to it, you'd have a total of negative 14x. You can mark it out and you can see that you have nothing left. So that means you have the most simplified answer. You combined all the like terms you possibly could. Oh wow, this has an equal sign in it. That means that we are looking at an equation. It's an equation. I see an equal sign and it also has letters in it, variables. That means that we'll be doing inverse operations to go through this entire process. So identifying what you see first. Okay, I see an equal sign. Cool. I've got an equation. Oh, I got letters. That means I need to solve everything in reverse. So starting with addition, subtraction. But wait, hold on. 2 letters. I got to combine like terms. All right, so that means I've got an x. There's no number in front of it, so that means I've got a 1x. And if you want to go ahead and put it's positive, go for it. Circling the other thing that I can combine with it, a positive 2x. We know that we are adding these. So 1x, I'm just going to put a little positive there. Positive here, 2x. If I have 1x and I add 2 more x's to it, I got 3x. This is where the first step in a multi-step equation would take place. Do you see any like terms? And the answer was yes, and we combine them. There are no more like terms on either side of the equal sign. So you could sit there and say, well, I see a negative 8 and I see a 7, but they're on opposite sides of the equal sign. Those would not be considered like terms. But whenever we start solving the equation, that's what we're going to end up doing, is getting rid of that minus 8. So I'm going to rewrite the problem. 3x minus 8 equals 7. So after we combine our like terms, next step is to rewrite. This is where we get back into our normal routine of solving a 2-step equation. So we know that whenever we're solving an equation, we're looking for the answer to a letter or a variable. That means we have to do PEMDAS in reverse. So the next step would be, do you see any addition or subtraction? Yeah, I see minus 8. So you would do plus 8. And negative 8 plus 8 is 0. I'm going to drop down that 3x. And 7 plus 8 is 15. Now we're down to a 1-step equation. A number next to a letter or a coefficient next to a variable always means multiplication. So that means we're going to do division. X equals 5. Okay. Now, if you wanted to substitute this answer back into this original problem, this is what it would look like. Just so we can make sure that it checks out. If it doesn't, that means we did something wrong. So instead of x, we're going to write 5 plus 2 times 5 minus 8, and it should equal 7. So this is where we see an equation, but we don't see a letter or a variable. That would mean that we use PEMDAS, order of operations, exactly how it was intended to be used. Do you see parentheses? Yes. Is there anything to do inside of them? No. Do you see any exponents? No. Do you see any multiplication or division? Yes. Multiplication. So we're going to rewrite. Okay. There's no more multiplication or division. Do you see addition or subtraction? Yes. What comes first when you solve the problem from left to right? Addition. 15 minus 8 equals 7. So 15 minus 8 is 7 equals 7. Awesome. That means our answer of 5 is 100% correct. We have an equation. 7 does equal 7. If that would have said 8 equals 7, then we'd have known that 5 is not the correct answer to substitute in for x. Last problem, just practicing combining like terms and then connecting it back to solving a two-step equation. So you can see here that, let's go ahead and divide the problem in half. That way we're not getting confused about what side we're looking at. There's nothing over on the right side. 8's all by itself. There's no like terms to worry about over there. I do see a 2x and a single x by itself. I'm going to go ahead and put a 1 right there. This minus 7 is all by itself. There are no regular numbers not followed by a variable on the left side of the equation, other than 2x and 1x. So I'm going to circle it. It doesn't have a sign, so it means it's positive. I'm going to circle the number with its sign, which means positive 1x. We know that we're going to be adding like terms, so that's going to be a positive 2x and a positive 1x. The structure that I'm going through and showing you right now is a system that will help you go through keeping your work organized in combining like terms and solving multi-step equations. There is not necessarily another format that you could do, so I would suggest working on the grammar of the math that you're getting into. 2x plus 1x will give you 3x. Now we rewrite the problem. All right, so 3x, and the only thing I didn't use was the minus 7. So minus 7 equals 8. This is where we're identifying, do we see like terms? Yes, we combine them. Cool. All right, we see an equation. We have a variable in it, or a letter. That means we have to solve in reverse. So opposite of everything you see, so opposite of PEMDAS. Do you see any addition or subtraction? Yes, subtracting 7. So the reverse of that is adding 7. Three x equals 15. We can get 5 again. Then we have 3 next to a letter, which means that we're multiplying 3 times x, which means that in reverse, we'd be dividing by 3. We're undoing what was done to get there. X equals 5. Again, if you wanted to go back and check and see if your answer is correct, which I highly encourage you to do because there's no reason why you should get a problem wrong if you can check it every single time. So 2 times 5 minus 7 plus 5 equals 8. Do you see any parentheses? Yes. Can you do anything inside of them? No. Do you see any exponents? No. Multiplication or division? Yep. 2 times 5 is 10 minus 7 plus 5. And if you look at what we're going to do now, all we're going to do is combine like terms. We have a 10, a negative 7, and a positive 5. None of those are followed by letters or variables, so that means that they're all like terms and they can be put together. This is the simplest version of combining like terms that you could possibly have. And you've been doing it for a very long time. Now we're just throwing letters in. If it has the same letter in the same way and it looks the same way, you combine those like terms. So solving from left to right, we got 3 plus 5. 3 plus 5 is 8. 8 does equal 8. We just checked that. Correct answer is 5. 100% sure. I encourage you to practice, ask questions.